Redrig just launched a major iteration of their trusted vCore platform, the highly anticipated vCore 4. This do-it-yourself printer promises to improve, to evolve, and to innovate. I pushed the enormous 500 to its limits with a series of tests. And yes, Redrig delivers. Even more, it's still underrated. Hybrid truly is next level for CoreXY. Lean back, stay tuned, and learn more about the Redrig vCore 4. Today's video is sponsored by the Red Magic 9 Pro gaming smartphone, the chill that never quits. With best-in-class performance, a stunning OLED screen, massive battery with an enormous charger, shoulder triggers, and a dedicated cooling fan, the Red Magic 9 Pro is the ultimate companion for daily use and competitive mobile gaming. I suck at mobile games, but it has never been easier to back up a marketing slogan like this one. Win more games is the promise when I get into some gaming while waiting for my 3D printers to finish. Check out how successful I've been with the Red Magic 9 Pro. And let's be honest, winning is just more fun, right? Powered by the Snapdragon 8 Gen 3 processor with a 120Hz refresh rate and a 960Hz touch sampling rate, this smartphone propels you to the top. The 6500 mAh battery and the 80-watt charger ensure a seamless and uninterrupted experience. For me personally, a huge and literal game changer is the 520Hz shoulder triggers, which have significantly boosted my gaming performance. And the 50-megapixel camera? Just see for yourself. Many of the recordings in this video were made with the Red Magic 9 Pro. Just look for the indicator during the video. Thanks a lot to Red Magic for sponsoring today's video. vCore 4 is Redrig's latest evolution in both design and setup, introducing numerous new features on the hardware and software sides. It features a simplified frame design, the possibility for an enclosure by default, and new motion system options. Hybrid CoreXY for higher speeds with quality printing, and it's prepared for IDEX, driving an additional independent toolhead for multi-material copy and mirror printing. For now, the default frame, available in 300, 400 and 500 sizes, is designed to be upgraded to IDEX or Hybrid CoreXY at any time. Redrig has paused the production of the 200 size due to low demand, which makes sense given the roughly €150 per 100mm price difference for the default vCore 4 kits. Hybrid CoreXY is an additional €100, but it's worth every cent. We'll dive into why later. IDEX requires parking positions for the toolheads on the 102mm longer x-axis, resulting in a 100mm larger footprint in x direction. The footprint in y direction remains roughly the same due to the new electronics box, though it's slightly shorter without it because of the simplified frame design. The formerly integrated electronics backpack of the vCore 3 has been abandoned, placing the motors inside the chamber. However, the high temperature and long shaft variants of the reliable 2504 LDO motors should handle this change effectively. The default electronics are now housed in a compact PC-like box at the rear. Inside you'll find a 250-watt Weiho power supply unit, a power inlet, an Octopus mainboard, a Raspberry Pi 4B with 1GB of RAM, a solid-state relay for the AC heat of the Printbed, and 3 cooling fans. When going at default setup only, this is both compact and tidy. Mothers might miss the spacious integrated electronics backpack of the vCore 3, as the new design leaves less room for additional modifications. On the positive side, compared to the vCore 3, all electronics, wires and essential panels are now included with the default kits. However, the top and front panels for the enclosure still need to be sourced by the customer, as Redrig doesn't offer these for kit builders at the moment. These are simple rectangular panels that can be drilled at home, eliminating the need for CNC machining or laser cutting. Looking ahead, Redrig is considering selling fully assembled and configured vCore 4 printers. So far, this has been done and tested with B2B customers and some reviewers like me. I received a ready-to-run vCore 4 500 hybrid delivered on a pallet. The machine arrived well packed and undamaged. Huge thanks to Redrig for sending this review unit. Shoutout also to my friend Hector from Fabrico for initiating the contact. An official offer for ready-built machines might be coming by the end of 2024, so if you prefer not to build it yourself, stay tuned. Prices seem to be affordable for that. Unpacking took some time and I was stunned by the sheer size of this massive printer. Along with the printer, there was an extra box containing a spool of Redrick PETG filament and boxes of pre-mounted components. The 1500 watt printbed came in a separate box and required mounting as well as some simple wiring. We initially set up a cheap IKEA table and a laptop in my garage, but that temporary setup was far from ideal for testing the VCore 4. The VCore 4 500 is a huge 3D printer without a display or a touchscreen, which meant a lot of running back and forth between the controls on the desk and the 3D printer. That's when I decided to go with a FlexiSpot E7Q standing desk, placing it right next to the VCore 4. I added a large monitor and an old workstation of mine to handle heavy tasks like slicing big models, recording 4K time-lapses, CAD and more. Most of the time I found myself standing at the desk. Working on the VCore 4 or in a workshop in general is just more dynamic compared to editing videos, for example. After an intense work week there, I realized that choosing the FlexiSpot E7Q was a fantastic decision. That standing test turned out to be the perfect solution for my workshop. Honest recommendation, great value for the price. So I was ready for some basic tests on the VCore 4 500, and at first I was curious about the heat up times of the huge, now 8mm instead of 6mm thick print bed, using a thermal camera and comparing surface versus sensor. As usual, the sensor is positioned at the bottom of the silicone heater and heats up to set temperature first. It takes around 2 minutes to reach 60 degrees Celsius on the sensor, 4.5 minutes for 80 degrees Celsius, 6.5 minutes for 100 degrees Celsius, and 8.5 minutes for 120 degrees Celsius on the sensor. Reaching these temperatures at the surface takes longer, also due to the increased thermal capacity of the new aluminum print bed. After waiting over 26 minutes, the surface reached 107 degrees Celsius at the set temperature of 120 degrees Celsius. Additionally, there's a temperature difference of over 10 degrees Celsius between the center and the edges. However, it's important to note that the absolute temperatures shown on my FLIR thermal cam may have an error margin of 5 to 10 degrees Celsius for those absolute surface temperatures. Nonetheless, the overall trend and message of this test remain clear. Allow the massive 8mm aluminum print bed to heat up sufficiently before performing any bed meshing or starting a print. Depending on the bed size and set temperature, it might be advisable to wait an additional 10 to 20 minutes after reaching the set temperature on the sensor. I wish there would be a switch to just drill a hole at the center of the aluminum bed and to insert the temperature sensor to where it belongs, on the print bed and not on the heater. While the print bed is still moved by the same 3-point and 3-motor kinematic as the VCore 3, there are now palm clips for the bed attachment and some geometric changes on the arms. Additionally, Redrick has upgraded the linear rails for the Z-axis from MGN12 to massive HG15, which is a welcome improvement. The toolhead has transitioned from the versatile EVA toolhead, familiar to VCore 3 users, to the standardized VCore 4 toolhead, included with default VCore 4 kits. This new toolhead features a Phaetos Rapido 2 Ultra High Flow hot end, an Orbiter 2.0 extruder, an EBB42 toolboard, a 4028 15,000 RPM part cooling fan, and the famous yet expensive Beacon surface scanner. Gone are the days of tinkering with separate ADXL sensors, as both the EBB42 board and the Beacon scanner now integrate acceleration sensors. While this default setup may not offer top-notch extrusion flow or ultra-lightweight components, it serves as a solid and modern starting point for a do-it-yourself printer like the VCore 4. According to Redrick, they put an emphasis on weight distribution and rigidity in this design. However, users looking to customize their setup will require a new aluminum top plate for their toolhead if they wish to use alternative extruders, hot ends or cooling solutions. Modders will find their ways, but it's gotten a bit harder. According to Redrick's calculations, the overall weight of the toolhead is approximately 520 grams, which is moderately lightweight, but still about 100 grams heavier than a Warren Stealth Burner with Clockwork 2. According to Redrick, the X-Gantry's calculated weight for the 300 version is around 1030 grams, 1150 grams for the 400 and 1260 grams from a VCore 4 500. This translates to a weight difference of approximately 110 to 120 grams per 100 mm. Consequently, the CoreXY system on my VCore 4500 must handle close to 1.8 kilograms, including the toolhead. This is where hybrid CoreXY comes to help, supporting the feasible maximum absolute acceleration with 2 additional motors and enhancing maximum quality acceleration with 2 extra 9mm belts dedicated to the Y components of the movement. Radrig's hybrid CoreXY integrates a Cartesian Y component to the existing CoreXY system, making it a hybrid of CoreXY and Cartesian kinematics. For an 100% X movement, only the 2 CoreXY motors are active and moving the toolhead only. For a 100% Y movement, all 4 motors move the gantry. Typical for CoreXY, the diagonal movement is performed by either the A or B motor, depending on the direction. But the hybrid motors support on the Y component of that movement. The input shaper graphs of each CoreXY and hybrid CoreXY provide interesting insight into each performance. Switching back to regular CoreXY from hybrid was straightforward. I simply decoupled the gantry from the hybrid's Cartesian belts and unplugged the hybrid motors from the mainboard to revert to regular CoreXY. The peak resonance for hybrid occurs at around 40% higher frequency and the recommended acceleration doubles. That's probably due to the dampening effect of the additional belts in the hybrid upgrade. With a recommended maximum acceleration of around 6000 mm per second squared for a 500 cubed VCore 4, Radrig's hybrid CoreXY showcases impressive performance. To test the advantage of an increased maximum acceleration due to hybrid CoreXY, I used my tool linked in the description. I set a fixed speed of 1000 mm per second and started with an acceleration of 14,000 mm per second squared. The toolhead performs each of those movements 10 times. Horizontal, diagonal, the other diagonal, and vertical. Each direction is repeated 10 times per iteration, with the acceleration increased by 2000 mm per second squared after each successful iteration until a motor loses steps. I repeated each test 3 times and more due to unexplainable outliers. For regular CoreXY without hybrid, step loss happened constantly at 16,000 mm per second squared during diagonal movement. With hybrid CoreXY, the motors mostly lost steps at 34,000 mm per second squared, though with occasional outliers at the low 20,000s. Now keep in mind, the test was performed at 1000 mm per second. This performance is impressive and gives a hint on what's possible concerning travel movement on a hybrid CoreXY. Well, does hybrid CoreXY double the maximum acceleration of CoreXY? Based on my non-scientific tests, it seems possible on my machine, though these outliers raise questions. Do you have an answer? Hit the comments, please. Mechanical synchronization, like on CoreXY all-wheel drive, should not be necessary here. Is it the belts or is the toolhead wiring counteracting? Regardless, Radrig's hybrid CoreXY is impressive. I expect it to become more common in CoreXY printers as a simple and cost-effective upgrade soon to be officially rolled out to Clipper. However, can the Rapido 2 Ultra High Flow and Orbiter 2 keep up with this high-performance motion system? Let's do some flow rate testing. Here is a quick rundown of the procedure. I automatically extrude 200 mm of filament into blobs at increasing extrusion rates and weigh them against a 100% weight reference sample. The weight difference indicates the amount of under-extrusion at increased rates. Around 5% under-extrusion is acceptable, although nozzle back pressure already increases, affecting pressure advance and therefore print quality during long extruded print moves. With the spacious VCore 4500 print bed, I tested each filament at 3 temperatures. Links to the tool and CNC Kitchen's explanatory video are in the description below. Sundlo PLA Plus at 220 degrees Celsius and 230 degrees Celsius performs well up to 30 cubic millimeters per second. At 240 degrees Celsius, it can reach close to 35 cubic millimeters per second. Radrig's PunkFill PETG was a surprise. Typically, PETG has lower extrusion performance, around half the rate of PLA or ABS, but Radrig's PunkFill PETG excels here. At 230 degrees Celsius, it can achieve 35 cubic millimeters per second. At 240 degrees Celsius, close to 40 cubic millimeters per second, and at 250 degrees Celsius, it comfortably hits 40 cubic millimeters per second. Seeing a PETG filament outperforming PLA is remarkable and highlights red rig filament's quality even though production is outsourced. I want more of that stuff. I love PETG. The last candidate, Eason ABS Plus, performs slightly better than Sunlu's PLA Plus, but still lags behind the red rig PETG. All in all, I expected more of the famous Rapido 2 Plus Ultra High Flow hot end at normal printing conditions, even with a 0.4mm nozzle. Since I'll need the full 500x500 print bed for upcoming projects on my channel, I wanted to see if I could achieve a perfect first layer using the beacon scanner. My attempt of a full 500x500 first layer failed unfortunately. The set offset between the nozzle and bed seemed to drift somehow while printing the infill from right to left. It started well at the front right corner, but gradually moved closer until I had to baby step the nozzle quite significantly during printing. My buddy N13D suggested to do an X-axis twist compensation by measuring the nozzle distance to bed at various X positions with the beacon bed mesh activated. The difference of about 1/10 of a millimeter from far left to far right made sense given the result of that full first layer. Considering the lever effect from the X-beam center to nozzle or from beacon to nozzle, only a very small twist angle is needed to cause a 1/10 of a millimeter offset from left to right. Additionally, there was a significant sag of the X-axis due to the toolhead being parked at the center of the beam during transport. Applying a bit of vertical force corrected this mostly. Eventually, I managed to print an almost perfect full 500x500 first layer. Nice! What wasn't nice were my initial attempts at printing models. I ran some quick tests like a 3D Benchy or a Mini Hulk to check the PLA profile I had to make. The 3D Benchy was a bit stringy and the Hulk looked as if it was printed with wet PLA filament. With the humidity around 65% at that time, this might have been possible, but seemed rather unusual based on my past experiences with PLA at my home. However, I undertook a major effort to dry all the filaments intended for use with the VCore 4. Shout out to Creality and Eyeballs for providing these dryers. The maxed out 500mm high Eiffel Tower print might be a mad stress test for the extruder, but it came out so bad after 14 hours that I was left puzzled. I began to doubt red rig's default settings for bridging, retracting and pressure advance all at once, as the Rapido 2 is still rather new hot end with a long melt zone. After numerous test prints to check various parameters, I found that only lowering temperatures seemed to provide some improvement. The salvation came from red rig telling me that there might be a bad batch of Rapido 2. Their temperature readings would be off by around 20 Kelvin and they run way too hot. And bingo! After receiving and mounting a confirmed good one, all problems were gone and I was able to print a good 500mm Eiffel Tower. If you run into similar problems, go and request a refund or a good one. The next print I attempted was one of my favorites, the 2015 Hulk from Thingiverse. Unfortunately, after over 1 day of printing, it turned out really bad due to severe under-extrusion issues. However, this time I quickly identified the problem and found the solution. It turned out that a certain position of the PTFE tube was prone to bending and folding, causing excessive drag. The high friction prevented the extruder from feeding filament towards the end of the print. To address this issue, I redesigned the corresponding part to use a coupler for 6mm PTFE tubes to relieve strain at the critical position. Additionally, I added a reverse Bowden filament guide to the filament holder at the bottom to improve filament feeding convenience when crawling on the floor. Links to the printable files below. These were the only significant flaws I encountered during my experience with the ready-built VCore 4. However, drag remains rather high on that 3.5 meter PTFE filament feeding. By the way, all the flow rate tests were repeated and the results I've shown before were done with the good batch Rapido 2 and with the PTFE tube fixed. My reprinted 500mm Hulk turned out great, with 0 issues during that long print. I increased the travel movement to 800mm per second at 30k acceleration without encountering any problems. This served as a nice test for that, given the extensive traveling involved in that now 21-hour print. I also tested enclosed printing, as I was curious about the temperatures to be reached in this huge volume of a VCore 4 500. After heating up the cavity for around 47 minutes at a bed temperature of 110 degrees Celsius, the chamber reached around 40 degrees Celsius, which can be enough for ABS. As I recorded the time-lapse, the temperature inside the chamber rose to nearly 47 degrees Celsius. FYI, ambient temperature in the garage was around 15 to 17 degrees Celsius during that night. Despite my still ongoing struggle with achieving consistent first layers, I was impressed by the quality of the printed part for the Red Chunk XY gantry, crafted from Christian's CR3D ABS FIP CR20 glass fiber filament. Additionally, a smaller print, a custom case for the Red Magic 9 Pro, was printed using Redrig's Punkfill PETG Green, a material and color combination that I'll revisit for sure in future projects. This whole endeavor consumed a total of 110 hours of printing time, along with continuous testing and troubleshooting. And I haven't even touched upon Nickel's remarkable RedOS 2.1, nor the seamless and smooth integration of Beacon's contact and True Zero meanwhile into the system. For sure, there's still much ground to cover and stories to share about the vCore 4, but I must bring this chapter to a close now. In the end, I want to sum up some negatives and suggestions I have noted during testing, mostly little things which don't destroy the good impression but worth mentioning. There is no AC grounding to the frame, only between bed, power supply and power switch. The flimsy hacks of the M2.5 countersunk nuts strip super easily, and one came even stripped from factory. That gave me a hard time changing the hot end. Also add a pack of spare fasteners in general to ready-built printers as well. With the spool holder inside the chamber, you're limited to 1 kg spools, and the over 3 mm long PTFE tubing of the 500 machine adds noticeable drag to the extrusion system. I can imagine this had influence on the flow rate test results. For easier repairs, also consider making sections for the PTFE tubing, not one crazy long one. Use PTFE tubes with an inner diameter between 2.5 mm and 2.9 mm. The one coming with the printer of 3 mm was too fragile and had to be replaced completely. For later iterations of the vCore 4, the toolhead wiring might hugely benefit from a robust horizontal drag chain like on Bambolab X1 or like Mikkel did on his vCore 3 in 2021. This would also enable a lower overall height of the vCore 4 for future iterations. For transport of assembled printers, park and fixate the toolhead at one corner. That long X-axis will sag eventually due to the weight of the toolhead. And yes, even though it's meant to be a do-it-yourself basis, I totally get this product, but at default there is no camera, no temperature sensor for the chamber and no filament runout sensor. Now that's it with nitpicking at the high level. With the vCore 4, Redrig delivered a surprisingly mature do-it-yourself printer. This counts for the hardware setup as well as for RedOS 2.1, which was a smooth experience during the testing time. The improvements made coming from vCore 3 are noticeable, but the real star is hybrid CoreXY. Literally doubling print acceleration at the same print quality is a huge improvement for CoreXY, and it's that next level stuff we need and want in our do-it-yourself printers. Do-it-yourself is dead? Long lives do-it-yourself. The value for money of those vCore 4 kits is hard to beat. The instant success of the vCore 4 speaks for itself. Actual lead time for new reservation, 12+ weeks. This won't be my last video with vCore 4. So, thanks for watching. Maybe subscribing, liking and spreading the word. Habidere and goodbye. Huge shout out to our 24/7 printing gold patrons, Eric Jung and Gutsby.